Good morning, good afternoon, good evening, wherever you may be joining us. And my name is Mark Richardson, Marketing Director with Vibrant Technology. And I am joined by Dan Ambray from Full Spectrum Diagnostics. And we welcome you all to another ODS Videos webinar. Gosh, I can't know. We are up to into the 20s, I believe, now of these webinars. So I appreciate everybody joining us. And today we are going to look at a comparison of MEscope ODS videos and traditional ODS accelerometer-based analysis. If you did or did not know, MEscope is the only ODS software that allows you to do both traditional accelerometer-based and video-based ODS analysis. So a key differentiator between us and a lot of the competition. And today we are going to look at a number of case studies Dan is going to share with us of where he used both videos and traditional based ODS to resolve numerous problems. And I think we have some really interesting stuff to show you today. We're going to get started with a walkthrough of the new MEscope NXT interface for doing ODS videos, and then we will get into a number of case studies after that, and then followed up, we will end the webinar with questions and answers. So if you do have questions, feel free to type those questions into the questions box there in the GoToWebinar panel on the right side of your screen, and we will get those questions answered at the tail end of the webinar. With that, let me hand things over to Dan, and we will get going.
Hello, everybody. Thanks for joining us. We're going to walk through a bunch of things today, and one of them is looking, like Mark said, at the NXT software. Those of you that have the current MEscope, you probably have something called VES, Visual Engineering Series, and it works really well for most functions of the MEscope software. But they have all kinds of applications that are linked to this. So data acquisition and modal and ODS and acoustics and finite element, and there's just too many menus. And instead of adding the ODS videos to that VES, I mean, it'll work in that software platform. They broke it off into NXT, and I'm a user of VES, and I thought I wouldn't like it, and I'm pleasantly surprised. I really like the NXT software. It's pretty user-friendly. There's not a whole lot of hidden menus you got to worry about, and it works good. And we're going to walk through that. I recognize that a lot of you that have been here before, but a lot of you haven't, and it's the first time you're going to see the software and the products of the software. So we're going to walk through a quick example. In fact, it's going to be this machine you're looking at right here. This is a belt-driven fan. And it turns out that they were having a lot of failures on fans like this. This is a rooftop. It's a concrete slab that's up there. It's a big rooftop. And several of the fans kept losing bearings due to vibration levels. And we decided to do an ODS, a traditional ODS of the entire deck. And we found that it was so flexible that it would be a better idea to put isolators under it. And we'll talk about this a little bit more in a minute or two, but you can see the two isolators out front. They changed two of them and they left two of them bottomed out. So it wasn't very helpful. So this is where we came in and took a video. It seems like it's backwards, but we took a video to see how our change was manifesting itself, and we had to go back in and add those other two isolators that were kind of bottomed out. Anyway, MEscope ODS videos, high-speed, non-contact video vibration analysis. The video clip is processed with the optical flow algorithm, which enhances subtle pixel displacements, rescales the video amplitudes. So if it's impossible to see with the naked eye, this processing allows the user to perceive in a video animation, either because the event is too fast or there's displacements are too small, or both are happening. And if they are both happening at the same time, it's like standing on the floor and shaking while you're looking at something that's shaking. If you can see it, it's too much, but we can categorize how much that is with the software tools here. As I just mentioned, well, maybe I didn't. MEscope ODS Video Software, it's a two-dimensional video clip capture format. And I keep telling people, you know, it's not the end all. It might be something that will detect the problem immediately. It might be something that'll push us in the right direction where we eventually will either need more data to look at more video clips, or we move it into doing a traditional accelerometer-based ODS analysis. So just remember that what I want you to stick in your head is this video software is two-dimensional. We're looking at X, Y. If we want to look at the third dimension, we have to move the camera. And in this case, we're almost end on. This would be vertical and horizontal we'd see, but we'd have to go from this side to get vertical and axial to show up. The 3D view kind of gives you a little picture into both of those, but not nearly as good as with accelerometer data. The accelerometer data is three-dimensional. We're taking X, Y, and Z measurements simultaneously. And when we do a bunch of measurement grids to get a good idea of how the frame's moving, how the motor's moving, how the fan's supported, then we will be able to see that three-dimensional response and be able to rotate it around and see what's really going on. And I mentioned the software includes the MEscope VES platform, as well as the NXT platform that we're kind of talking about today. And it'll be the first time that I've shown it. What's key with the MEscope video software? Time waveform animation source, digital Fourier transform animation source, and we can calculate ODS FRFs from any set of video data, and that allows averaging, overlap processing, and direct capture of cross-channel phase. So there's multiple things that the ODS video software does that no other vendor does. And I think Mark touched on it. I use the iPhone 10 because that's the latest version that I have. You put it in slow-mo video capture, and you can import this right into the MEscope ODS videos and start your analysis. Okay, so everybody has a dump truck full of transducers in their pocket, and they pull it out in the form of a cell phone. And we'll talk some more about that as we go.
Hey, Dan, while you're on that, I'm sorry, when you're on that page there, just wanted to let everybody know that if they have a current VES license, you can download NXT right off of the Vibrant website. So it is included with your VES license. There's no additional purchase if you already have a VES license.
You need VES
yeah.
ODS Pro.
Correct. Yes.
Correct.
Yeah.
So if you have ODS Pro or better,
you can
use it.
You can certainly use NXT. Absolutely.
Okay, I'm going to take a break from the PowerPoint. I'm going to go into the NXT software. So there's recent projects. You can acquire video directly from the camera in some applications. I get raw video from file that I dump to my computer, and you can open different projects. So we're going to click on the raw video from file, and I come into the wizard software. So adjust and crop, frame and elapsed times, grid points, scaling distance, magnitude history, and point graphics are all the little steps we're going to walk through here to get our video in the proper frame of mind to show us what's going on. We're going to open a raw video. I click on that and bypass all these pictures of machines and prom. And here we are. I want to grab this one. This is the one we just saw. This is a belt-driven fan on a flexible frame structure with isolators, and the floor is moving. Okay, so there's a lot going on. I can get in here and adjust the brightness, more or less. I can adjust the contrast, but with an iPhone, you get a spectacular picture even in really dark conditions. So you're losing a little bit of the high speed part of it. Like you can go 500 frames per second. This is 240 frames per second, but in that frequency range is about 90% of faults that are phase related that we can actually see. instead of, things that aren't making enough vibration or don't go into a pattern. So an ODS shape is extended into the video range, and we can process it and look at it. And once we rescale all the pixels. So we got the brightness and contrast. We can rotate this if we took it with the camera on its side. This one we brought in normally. We can crop it and such. I'm going to leave it like this. Now I've taken about 15 seconds of data. That's the best fight against getting corrupted data. When you touch the phone, when you turn it on, you are moving the phone and you're moving the tripod and you're shaking the visual image of whatever you're testing, okay? So the best way around that is to get a few seconds away from that transient on both ends. When you touch the phone to turn it off, same sort of deal. So if I take roughly 3 seconds in the middle, here's my little 3.18 seconds, and we'll knock it down real quick and just take 3. There we go. Okay, about 3 seconds of data is just about right. The longer you take it, if I took 10 seconds, it's going to take longer to process the data, but you're going to get better averaging. If you're doing the ODS FRF calculations, you'll get much better averaging and noise floor reduction. So it depends on what you're doing. If you're just looking at the video, 3 seconds is plenty to see the shapes and how it's moving. If you're going to do some signal processing, then a longer frame of reference might be required, okay? In this case, about 3 seconds, here's a rough grid. I'm gonna bump this up so it's a pretty sharp grid, around 10,000 points in this field of view. Now this is not every pixel, this is just a sampling of those pixels. If I did every pixel, the whole screen would turn red with dots. And you don't really need it for all the, you don't need that kind of resolution for what we're doing, okay? So this will be 10,764X and 10,764Y time waveforms that'll be generated. So every one of these dots, I'm going to extract a time waveform in the X and Y directions. If I want the Z direction coming in and out of this plane, I'm going to have to move the camera 90 degrees and get that information. So it goes fairly quick. We're about 15% into it, 1 minute and 48 seconds left. Let's see, what can I talk about for 1 minute and 46? There is a background noise reduction we're going to do next as soon as this completes its little journey. Background noise reduction allows us to put in a tool and we can draw areas that we want to be that are in the background that shouldn't be moving. If the camera's moving, if the floor that the camera's sitting on is moving, if it's windy out and it moves the camera, everything in the field of view gets moved, and it's all background noise that really isn't there. So I want to turn all this off. I want to turn off anything in the background around the operating unit, and what it'll do is it'll calculate the background, and it'll take the average, and it'll subtract that average background motion from everything, okay? And then it will set all the points selected in the background to 0. So now what's really moving is just the parts that should be moving, and it should be at the correct amplitude, or much closer to the correct amplitudes. So I still have 30 seconds, and I talk fast, but maybe I ought to slow it down a little bit. Some of the data we got from this, there's several peaks, and one thing that we're going to do next week we're going to talk about aliasing in a video clip and anti-aliasing. And in an accelerometer, you have anti-aliasing filters, or in the digital processing that the accelerometer dumps to. We have hard analog filters that will chop the vibration off at Fmax. That doesn't occur in a video clip. There will be frequencies above Fmax that fold back into the signal that'll give us problems. And we're going to locate and remove those next week. And in fact, Mark Richardson just told me about this. There's an Fmax at 240 with your cell phone. A usable Fmax range in the frequency spectrum is half of that, or the Nyquist frequency, which would be 120 hertz. This unfolds all that, so we get actual data up to 240. So it's really nice, and we're going to play with that a little bit next week. Okay, so I'm done. I'm going to set a distance, a known distance. And I'm going to go from here to here because I know this is a 12-inch I-beam frame. So 12 inches is my set distance, so the camera knows where it is and how to scale everything. Click my next button, I get this magnitude histogram. And what this does is it looks for large motion at very low frequency or small motions at very high frequency that might be in the background, and you can try to zero in on what matters to you, this histogram area. The closer you are to the center of that histogram is nice, and that's really what you want. I don't use this nearly as much as I used to because the remove background tools are much better. And so I'm gonna do it that way. I'm gonna pull these back out. And I light up all my red grid points, and I'm gonna work it from a different angle. So I'll go to next. We have a whole bunch of selections here, and we're not gonna go into these today. We'll probably do some of that next time. We have the webinar. In addition to the aliasing stuff, we're gonna get more into the labels and vectors and so forth. But you can select points on the drawing or on the video frame, and you can ask for a vector to show up. You can do a label with mag and phase. You can do orbits, and it's kind of nice. If I had I'm almost right head direct on this radial position or the axial position, so I would get a radial orbit that would look pretty nice in here. But we'll save that for another time. So I'm finished with this. It's going to load up a different set of windows. There we go. The top window is time waveform. Okay, and it's sweeping through that time waveform a little fast, but it's going through right now. So the time waveform, let me slow it down a little bit. Maybe that'll help. So you can see it bouncing. It's bouncing at multiple frequencies, right? When I do the FFT of this time waveform, I'm seeing these peaks, and this is an enveloped overlay, and there's a couple of peaks right here, and I think this one is yeah, there we go. This is the one I was looking for, 1680, and I believe that's the speed of the motor. It's on a variable frequency drive. This is 1780, which actually this might be the motor. This might be a multiple of fan speed. But anyway, 1780, I get a bouncing frequency. Everything's going up and down. I still need to remove the background and get rid of that, but this is the one that's more interesting to me. Whoop. Sorry about that. This is interesting because of the twist in the motor. So it could be coming from too tight of a belt, or a eccentric pulley, something like that, or it's just the frame is pitching as it's bouncing. And we might definitely would need another view to see what's going on in here. Okay, we're going to do the background removal. So there's a little drop-down menu, has a whole bunch of things with editing and calculating ODS FRFs, time waveform at a cursor, all kinds of reprocessing. We're going to remove background motion. We're going to do a closed outline, and basically we draw a line or an enclosed area. Bear with me. And there's my first section. it took the opposite section, so I want to invert it. So all the red points here are background. There's, I want to do an interactive point selection and add more enclosures around here. So I'm going to do something like this. That's background. Here's background. And maybe something in here. And you can always go back and do this over again if you have problems. There's no limit to that. Okay, so good enough. We're going to accept this as background. So now it's going to do the calculations where it finds the average of the background, removes it from all the frames, and then sets all the selected background to 0. And I did take 10,700 points, which is probably a lot for a demo, but it makes it look better, and I'm a stickler for that. So I left the cursor here and here. There's that 1680. And it's looking pretty good. I'm going to zoom in a little bit. And I can drop my amplitude a little bit to get it a little less edgy. I can turn on my contours. And it's a little different animal. Everybody out in the audience, if you've taken data before, you're taking it a horizontal, vertical, and axial somewhere, trying to get as close to the bearing housing as possible when you take that data. You see big vibration, the dominant vibration, and if that's my color key, bring it down here. If I have the highest vibration, this is in inches, so 15 thousandths of an inch, that's probably this. The really high vibration is not where you're measuring all the time. It's stuff like this. It's the sheet metal buffeting, all kinds of things that you have to worry about now. But when you use that label command that we didn't go through, you could select some points and get a label and see exactly where you normally would take data. And that's going to be the future of trending. You might walk around with your iPad and take a video of a marker on the housing. So you're replacing your accelerometer with a sticker and a high-speed video, which should be very quick to take your data. You don't have to touch anything. You don't have to lug any equipment around. Just to have a tablet that has a camera in it, and that's it. So that's about how it works. So I have taken this and I put contours on it and take them out. I've removed the background. Now I can start doing my signal processing. You'll notice this is in, this kind of bugs me. I would rather see a linear format. Makes a little more sense to me. And you can, since you're taking phase across the entire spectrum, you can pick any point you want. So this is a vertical bouncing mode at that corner of the skid that the motor's sitting on. And let's see what this is. Something similar. You know, there's all kinds of rigid body modes and flexural modes, and we'll pick those out. And any of them close to running speeds, that's where we have difficulty a lot of times in vibration analysis. Okay, I'm going to go back to where I left off. This is a little case history of a pump in a refinery, and these guys need to be turned on. So they're bouncing basically. This was, I came into this refinery, I went and I have my cell phone, didn't have my high-speed camera, For normal purposes, this wouldn't be a problem because I'm looking at turning speed of the shaft, which is about 3,600, I believe. Yeah. But the problem was at blade pass frequency, which was 5 times higher than that, which was above my F max on my cell phone. So instead of going and getting all the equipment, we decided to do an ODS, traditional ODS analysis on it. So we got out the sketchbook and found where we're going to take all our data and started mapping it out with our accelerometers. And this is what we saw for 1 times RPM. So there is a little bit of bouncing to it. They were in different conditions when this data was taken compared to this data. They had some pressure loads that were different in the pump at high performance, and I think that's what we were seeing here. So there is a little bit of vibration. When you look at the scale of things, it's only about 0.15 inches per second. So it's pretty small compared to the blade pass frequency, which is right here. So the blade pass frequency, when we animated that, that's where the interest really started peaking. We took a lot of foundation data, and then we came up the pump stand, and then we started taking some across some of these connections, and we were seeing very high vibration, and it was nearly 2 inches per second. When we got back and reprocessed all this data and made this animation, there's this twisting motion, a torsional mode in the bearing housing. And, we're at that point, we were trying to figure out what to do next. I believe what they settled on for now was not operating at the conditions that they were doing here. The real good high performance, they'd love to operate here, but they dialed it back a little bit so that they wouldn't cause any more problems. This is the fan unit that we just talked about, and I like this view. This was also a little backwards. We did the ODS on the floor first. So gridded out the floor, took a whole bunch of measurements, and from underneath we could see where the stiffener I-beams were, and there was really no way of stiffening this floor. There was a lot of folks that didn't want to do the isolators. They didn't believe in them, and they wanted to run a bunch of beams everywhere. But with the way it was set up, such large spans, it would have been it was really impractical. It was difficult to do it that way. Okay, a couple of things came out from this, and I'm like, man, that's really bouncing, because it is amplified, but it's strange that you have that much, especially you zoom in and you see the spring motion go. But it turned out that they just installed these. They tried to use the same holes that the other bottomed out isolators were in, and it caused some problems. They were a different size isolator, and so they left the old ones in on the back side. So you have something that's has 4 isolators that's probably needs 6 to do all the work, and only 2 of them are actually reacting the way they should. So the vibration in the area was up pretty high. And this is that same shot on the corner of the skid just to see what the motor's doing. I assume that they might have over tightened the belt, or they might have an eccentric pulley on this end that's giving you that push and pull every revolution, that operating shape. And put a little color on it. You can see where stuff's really moving. So there's a couple of orange spots on the housing here, and it's kind of sheet metal. We don't want to take vibration if we're looking for bearing defects and things like that, but a lot of sheet metal response and cabling. In this case, the connection for the motor was bouncing around. So it's nice to have a color contour format to see what's going on as well. This is in the same plant. This is pulverizing equipment. So what you see all over the little dusty stuff is powdered corn. So it's a high-speed motor, 3,600 RPM, spinning a couple wheels, and it's either crushed or sheared or just mechanically pulverized into dust, and it's dropped down through the floor below. So corn comes in the top, dust goes through in the deck below, and it's taken away and goes through some other processing. This is what was interesting, is the whole thing is kind of bouncing or sliding, and it's sitting on, it has a bolt through it, but it's a rubber isolator right here. So they really aren't fully bolted down. It's a pretty loose connection. And you get a little bit of sliding type motion in and out of the page here. But it's a nice kind of ghostly image. This is another grinding machine. So this is a secondary grinding. So that all that corn powder comes down and goes through this, and they have a bunch of different grades. So they can change the engagement with this wheel, which throws everything off. So there's an alignment feature. You know, they try to hit a sweet spot in the middle where they have a little leeway between processes of different fine grinds that they need. As a result, you know, they introduce unbalance and misalignment and all kinds of things in the whole structure. So what you're seeing is one of those modes, one of those bouncing modes of the whole structure. This is a floor, and I do a lot of floors, and I keep learning more and more about how this works. And it probably would have worked a lot better if I would have gotten a broom and broomed off that entire area. But the way this powder is, if I did that, I'd turn around and have to redo it all the way back. It's just constant powder everywhere. So you can see the motion. There's tracks in it. There's little things that you can see underneath. And I believe the camera has a hard time distinguishing smooth surfaces, obviously, but also surfaces like this that are covered with some kind of dust. It can't fully get a good picture of what's going on. The color helps a little bit. And there's a little pitching and a little bouncing to this floor. If you go and walk on it, you definitely know it's shaking. So we were trying to see if there was a shape to it, if there's a node line somewhere or what have you, so we could figure out if we need to fix it or not. This is another area. It was between the pulverizers. So there's an aisleway. There was 4 pulverizers on either side, and you can see the motion. And this one shows up a little better in the color contour. So as it's going down out here, it's going up in here, and vice versa. And it's kind of interesting to look at to see what the response is. This is a centrifuge area, so they take some of the corn dust and put it in a slurry, and this pulls some sugars out of it or something. I didn't know exactly what the process was for this, but this is the drive motor on one end of the centrifuge, and it's sitting on a platform, and it has 4 isolators under its feet. And it's supposed to help with the vibration, but the floor shaken, all the machines were shaken. This is a pretty high response, so all vertical, and it didn't look to me like there was a whole lot of motion that these were providing, or isolation that was being provided. But you can see what you normally can't see. So there's all kinds of things, possibilities at this point. Now this, some of you, if you've been on here before, might have seen this. I think a couple of webinars ago, I was at a plant with an air-cooled condenser cooling tower. And you can see the diamond plate decking. And the motor's bouncing around, and this other motor's bouncing. This is the cooling tower. So in here is a long shaft. There's a right angle gearbox, and there was a 7-bladed fan up here, and the blades go by about right there. There's a little porthole that you can look in and see the blades going around, but as far as taking video, it's a little difficult with a blade that's swashing by every fraction of a second. But the floor was shaking. So they had a resonance condition right at blade pass. And I say within 2%, it was at least that close. It was right on top of it. I did a little bump test, found the natural frequency of the motor, and it was the same frequency. So we were trying to figure out what the deck was actually doing, because it was, we put a 10,000 pound cube of cement. We had a crane operator drop that on the deck at multiple places, and we were trying to mass load it to see if we could move the natural frequency and live with that. And it wasn't responsive any way you'd think. The motor vibration would go up or the gearbox vibration would go up, but they both wouldn't go down at the same time. But there's a standing wave in here. This is the one that's operating. So this is the cell that's operating. None of the other ones are. So this motor was shaking just as much as that motor, and it wasn't operating. And you can see the deck here. Here's the crossway, where this is one of the 4 units, that's one of the 4, that's one of the 4, and so forth. And they're all isolated from each other, and I don't know why they were all reacting together, but it was a pretty serious resonance condition. The deck was on the order of 0.7 to 1 inch per second. And the one thing I wanted to talk about today was, remember we just talked about the 4 in the plant where they were pulverizing corn, and this is diamond plating. So it has what looks like a grid all over it. So this is a beautiful product to use for looking at a floor, because it's reflecting off all those points. Over here, you have the shade, and it doesn't have that responsiveness in here, because it's all darker. It's darker color. It's like throwing that pulverized corn all over it, and you don't get a uniform, or you get a uniform surface. You don't get this non-uniformity that allows you to see the mode shapes in the floor. And this one is the next door neighbor. He's not running. This guy over here that we just looked at, he's running. So all this energy is going across, and you can see it's going up here, it's going down there. So there's definitely a mode shape in the decking, and it's very sensitive. It's all at blade pass frequency. And if I put the color contours on, it's basically a bending mode. There's a node line, and there's something else out here that I can't quite see, but as this side goes up, that side goes down. So it was still 1 inch per second, but it wasn't even operating. It was kind of an amazing thing. And they had like 48 of these, and they were all doing this, and so it was a big problem. This is one that somebody in the plant sent me before I came. So they stood at the back end of this thing, and it almost looks like they had a tripod, because they were standing pretty still. But they shot this short video. It was right around blade pass frequency, and the whole deck was moving. It was interesting. Now, traditional ODS, a couple of things we couldn't do. We could take data all over this decking and all over the motor, but we couldn't take it here, not the same way. So I could shoot a video and that would work, but I couldn't do it on the inside. So we didn't know exactly what was going on in here, but the gearbox vibration was high. So we took measurements all the way along each edge, each I-beam, and this walkway wasn't solid. It was a gridding so that the air could move through it. But this deck was moving, and it was out of phase with the gearbox out there. Here's a view from the other direction. So very high vibration, up to 1.3 inches per second, and a little less than that down here on the deck. It was 0.7, 0.8 in here, but still way too much for what this fan was supposed to do. This is a fan motor side of a fan and a fan frame in a cement plant. And again, we got cement dust everywhere. So that's one of the drawbacks of this. When you get some product or sand or what have you, or it's just a flat painted surface, it's really difficult to pull floor response out of unless you can get the right angle and get far enough away. Then it might work, but it's difficult sometimes, and it's in this case easy because it looked like it's bouncing on its isolators. This was a bolt bound unit, and I believe what happened, or was continuing to happen, is they were loading it to one end so far to get their alignment that they stiffened up this A-frame, and they ran into the natural frequency and it started shaking. Okay, and I've never been able to take data while the unit's not operating to see where that natural frequency is, but I did take operating deflection shape data in 2006, I believe, and this is the ODS from back then, which looks a lot like the ODS now. So horizontal kind of sliding motion, concentrated on the outboard side, outboard motor end, and that's what this was. So the way around this was to install some beams and stiffen the structure up, but I don't think they actually did that at that point. And again, there's cement dust all over, making it difficult. The nice thing about this software, one of the nicer things is you can see what's happening. You can remove the background or you can remove the foreground. This is what happens when you're on a cooling tower deck, when it's the deck's bouncing, the cowling around the fan is bouncing all over the place and shaking, the motor's shaking, and it's windy. And I believe I was holding the camera, so it wasn't even on a tripod, which is playing with all the bad buttons there. So there's a lot of things going on. The remove background tool is outstanding for controlling this type of thing. This is when I select the structure that's the motor and its support structure and the beam that it's mounted on, this cylinder. I can remove all the cowling vibration, the floor vibration, and so forth, get rid of the wind, pushing the camera around and causing everything to look like it's shaking, and now I get the true motion. Okay, I can do the same thing with removing the structure that we just talked about and keeping the background. Oh, come on, what's going on? It's not letting me play that one. Might play in a second. Anyway, so now I can see what the background looks like and how it's moving. Yeah, it would be not. That one locked up on me for some reason. This is a belt-driven fan sitting on a deck in a cement plant. And again, it had dust everywhere, but this is diamond plating. So it had a bit of a pattern that you could still see. It wasn't as difficult as one of the other problems we had with the corn dust one. They thought it was misalignment. They thought they were having bearing defects. They thought all kinds of things. What they were having is a deck that was fairly flimsy that was supporting this fan. So there was no isolators under here, no rubber pads or anything, just the diamond plating, and the beams were not quite set in the right place. And I believe this image allowed them to, oh, you know what? It's not letting me. Here we go. There we go. Sorry about that. The beams weren't allowing them to fix the problem because nobody knew to look underneath and move the beams around until they saw this, and then they could figure out what they needed to do. Now, not every floor can be done with a camera. This is one of the cases. This is a very low lit power plant, and it was a big ID fan. It was on a very elevated floor. There was limited beams underneath it, and a whole corner, a whole half of this fan foundation was moving. And I didn't ever find out how long it's been doing this, but the vibration was very high. So with the color content, it goes kind of in this range, about 0.15 inches per second. 0.05, so something if it was just yellow, that would be acceptable. Anything else above this yellow 0.055 would be extreme for this type of response, especially on a foundation. Okay, so I had to do this with, I think, a 2-foot grid, a couple hundred measurements on the floor, and fairly easy to see what was going on. And this is another fan, same place, 1200 or 700 RPM motor speed, but it was dipping here. So we had a little mode shape going on there. So same deal. This is 0.1 inches per second plus, and it's about twice as high as it should be for a foundation. At least that's my experience from lots of different floors and foundations like this. This is a pulverizer in a ethanol plant. So corn pulverizer, when they took it up to 1800 RPM, and it was 1757, something like that, the floor just went into this horrendous vibrating mode. Same deal, took measurements on the pulverizer, the motor, the frame here, and then we did a grid on the deck. And you can see what the mode shape looks like, and pretty profound. They ended up, I believe there was an existing beam under here, and they put a beam right through the middle. Oh, I guess I couldn't. Just on the outside of the pulverizer, there's a chute that goes down right underneath it. And it was enough of an obstruction and a stiffness increasing that it pushed the natural frequency out of the operating speed range. So just knowing where you are, what the mode shape looks like, that's the key to fixing resonance problems like this. All right, I think that's all I have for today as far as examples. I did have one other thing that Mark just talked about earlier, the MEscope ODS Videos software package. You can use it with the legacy software. So if you're a MEscope user, the VES is your thing. You can get a version of it for that. Or you can try the new NXT version, which we just saw in action right at the beginning of this presentation. The other thing you get, this is the video software. It's a separate product from Vibrant, but to make this work, you need ODS Pro. ODS Pro is signal processing. When you have that, you can do the traditional accelerometer-based ODS analysis. Okay, so no existing MEscope software, $13,995. What does that get you? It gets you the software. It gets you both ODS videos and ODS traditional ODS if you want to do both. And actually, it'll get you modal too. It just won't give you curve fitting. So it can be stretched into a lot of different directions. So it's quite a bit. Anyway, no existing MEscope software, $14,000. If you have the basic software and it's just visual ODS, the upgrade would be $9,000 to get you the ODS Video and ODS Pro. If you have ODS Pro, it's $6,000 for the ODS Video software. Anything, Mark, that you? Oh, one other thing is that if you have an existing camera, like I have a Kronos camera, and it's made in Canada, it's very high speed, it's a really nice camera, but my cell phone camera works better than that. I use my cell phone for every job like this. There's really not a reason to get a really expensive camera, but if you have one, you can use it, obviously. If you have a Kronos camera, if you have an Iris camera, if you have any vendor high-speed camera, you can use it. And some of those cameras require lights, and that's one of the reasons. It's a great camera, the Kronos, but it's a light hog when you're in a dark area, and it's difficult to get a good video representation. The iPhones don't care really how dark it is. They put out, they open their iris really big and they take in a lot of light so they can get better pictures. Anything else, Mark, that you think of?
We got a couple questions here. Pat McCarg at Vibrant wanted to remind everyone that if you want to remove camera shake, you might mention using an external Bluetooth handheld trigger. I think you use that, don't you, Dan, with some of your?
Yeah, I did for the Kronos camera. For my cell phone camera, I have a tripod with a little spring-loaded thing, so I can just touch the start and stop button real easily. I don't know if they make an on-off one for iPhones. It'd be nice to know.
Oh, I'm sure they do. Yeah, I'm sure they sell that. Next comment, might want to show result sets. I don't know where that was. Show result sets. I think that was when kind of earlier in your presentation.
Yeah, the result sets, here, real quick. Okay, I'm gonna cancel this. In here, switch result sets, so I can go into that. This is the original, and then I remove background. If I do an ODS FRF, and I don't know how long this will take, but if I do an ODS FRF set, now I'm not sure that's going to be a quick thing. That would turn into another, I put a reference point on here somewhere, like there, that's where I'd normally take my data. I can get a different block size and number of averages, and I'm just gonna accept, and it's gonna do some overlap processing. It's gonna give me 25 averages, and it's gonna convert all my data into ODS FRF data, and it'll give me another set, measurement set, if I'm saying that right. Probably put myself in an infinite loop. Oh, there we go. So here now it's, I have my time waveform, I have my ODS FRF envelope, and I can animate from this as well as the other ones. There's my 1800. Here's the one that was of interest to me because it was twisting. If I go back in here, I can switch back to wherever I want. I can go back to this, I can go back to the original and restart and do everything over again if I want to. I think that's what Pat was saying.
Yeah. If anybody else has any additional questions, feel free to type those into the panel there. Did have a question about trial versions from Greg. We have high-speed cameras, but not sure how well they would work with them. Greg, there's a couple of options we can do for you. If you want to send us your video file, we'd be happy to process that and send you the results, just so you can get a sense of if it works for you. We do accept numerous different file formats: AVI.MOV, MP4. They're all listed on our website, so you can take a look at that. In addition, I did want to let everybody know that there is a way to purchase the software on a monthly license. If you go out to our website and you go to the store, you can purchase ODS videos on a monthly subscription. I believe it's at $839. And that goes for all the MEscope, or most of the MEscope packages. You can also license on a monthly subscription as well. So that's a low-cost way to get in. And if you're working on a project, so on and so forth, and you're only going to be there for a short period of time, and you don't want to purchase the whole full-blown version, you can license the MEscope software on a monthly basis. Can you animate multiple peaks at the same time, say filtering out motion we aren't interested in? I'm not sure if I understand that. Can you animate multiple peaks at the same time, say filtering out motion we aren't interested in?
Well, you can select any point, any peak you want. And you don't have, like some of the other vendors out there, they have to reprocess all their data for every frequency they pick. But if you just pick like those two frequencies, 1680 and 1790, whatever I had up there, those will animate just at those frequencies. As far as background noise, that's a kind of a whole different story. You do need some type of background noise reduction, like I've showed you, to make sure you don't have good video. Hopefully that made sense.
Mm-hmm.
Anything else?
All right. None other questions right now.
Well, if you're out there and you're on the fence, give me a call and let me, maybe I can process a video for you and see what you think. The seeing is believing. So if you go out to your plant and take a picture of something that's not operating in a good way, the first one's on me.
You can reach Dan at modalguy@aol.com, and you can reach out to us at Vibrant at sales@vibetech.com. If you have any follow-up questions that you want us to get answered for you, or if you have a video you want us to process for you, we'd be happy to take a look at it for you and send you the results. In addition, we are recording this video. I just forgot to mention that at the beginning of the webinar. So we are recording this webinar. We will get this put out on our YouTube channel probably in a couple days. And there is an entire catalog of all of the past webinars. So if you're new here, I encourage you to go out and take a look at those YouTube videos, and you can view the last 20-some webinars we've done. In addition, you can get some great tutorials on the rest of the MEscope packages. Any last things you want to add, Dan?
No, I'm all out of words.
All righty, excellent. Well, very good. I thank you all for joining us, and I thank you all for being an MEscope customer. We couldn't do this without you guys, and so we really appreciate your support. And stay tuned. We will get another webinar spun up here next month, so keep an eye out on your emails. Again, if you have any questions, feel free to contact us, and we will be happy to help you out.